Right, so here is a video showing you how to simulate the circuit using CAD. So we've been provided with this circuit diagram for a digital metronome. We basically need to build it, and then we need to test it, essentially, see what value we get. So the circuit diagram is generally as it looks. The only sort of main issue is the 555 timing chip there. It's really not that clear what's wired to what. So I've provided this sort of slightly neater diagram to kind of help see where everything goes. Right, so let's get stuck in. So we should get CAD. So here's one I made earlier. So I'm going to show you how to make this from scratch. So we go to CAD. Our home page should look something like this. We need to have registered and things like that. So we go create, we go to circuits, and then we can start building our circuits. So the first thing we're going to do is put in all the components. Then I'm going to start wiring them up. And I'm also going to make sure and double check I've got all the right values. So if we click on our battery, 1.5 battery, put it in, this little box will come up. So what we need to do is set that to 3 batteries. And then I'm also going to rotate this round so it's the way it should look. And then I'm going to add a switch. Now it has a sliding switch, so it has 3 terminals instead of just 2. So we'll basically connect it from terminal 1 to the common, and then we just won't connect anything to terminal 2, and then that will be off. So you'd use that if you wanted to switch between 2 circuits. In this case, we're doing it for just 1. I then need resistors. So I need this resistor to be 100 kiloohms. No, I don't. I need it to be 10 kiloohms. Okay. I need another one that needs to be 330 ohms. So I'm going to 330 and then click on that drop down, change that to ohms. And then I need an LED. Now you'll notice in the diagram, if we go back to it, one leg of the LED is longer than the other. So the longer leg is the anode, the shorter leg is cathode. So the anode should be connected to the positive sort of terminals, and the shorter one should be the negative. So we've got the cathode on the bottom, the anode on the top. So it should look like that when it's the right orientation. If when you try and simulate your circuit that doesn't light at all, the first thing you might want to do is turn it around, because that's probably where you've gone wrong. We then need our NPN transistor. So I'm going to pop that in, and I'm going to rotate it around so it's the right way. I then need a capacitor. I'm going to pop that in there. Again, I'm going to rotate that round, and I need to set that to 10 microfarads. Okay, so that's now 10 microfarads, and then I need my variable resistor, or that type of variable resistor is actually called a potentiometer. I don't need to put potato in, just potentiometer will do. And I'm going to rotate that round, and again I'm going to set that to the values it says in the circuit, which is 100 kiloohms. Right, so that's all my components. I'm just going to go quickly around, check all the values. So I've got 10 kiloohms, which is correct. I've got 330 ohms, which is correct. I've got 10 microohms, which is correct. And I've got 100 kiloohms, which is correct. And then the last thing I need to add, of course, is the 555 timing chip, and pop that in there. Okay, right, so now we're ready to start connecting this all together. So I'm going to basically start by doing the branches that don't involve the chip first, because that's more complicated, and it's just important to make sure we get things the right way around. So I'm going to go from the positive terminal up to my switch to terminal 1. I'm going to make this slightly neater by sort of clicking it around to make it more square. And then I'm going to go from the common across down to that resistor, and then from that resistor to the terminal 2 on my variable resistor, and then from the wiper to my capacitor, and then my capacitor to the negative terminal. So that's my first loop. Now, annoyingly, with CAD, you can only connects from the end of components. I can't sort of create a junction in the middle, or I've not figured a way out to do it anyway. So I'm going to go from the top of that resistor to the top of that one, from terminal 1 to the anode, from the cathode to the collector pin, and then from the emitter pin to terminal 2, that bottom sort of negative terminal of my capacitor. Right, so that's the easy part of this. So if we look at the circuit diagram they've provided, as I say, it's really not that clear what's connected to what on that, because if we look at sort of, for instance, that section there, it's really quite difficult to figure out what has been connected to what. So I've provided you with this slightly clearer version, and hopefully when we've done all these connections it should work. So yeah, so we need to basically mirror those connections in Tinkercad. Okay, so let's start off with pin 1, the ground. So pin 1, ground, goes from here to the negative terminal, the battery pack. So I could connect it there. I could also actually connect it there. It's the same difference, but I'm going to stick with what it says. Whoops, and I'm going to connect it to the negative terminal of the battery pack, which is there. No, still not got it. For some reason, CAD is being awkward. There we are. Right. Okay, so then pin 2. So pin 2, we need to go from here to here. So we've got pin 1, 2, 3, 4, and I think it goes 5, 6, 7, 8. We don't need to worry about the numbers. There's too much. Pin 3 goes from the output, which is pin 3, to the middle pin, or the B pin of our transistor, the base pin. And then pin 4 goes to this pin here, pin 5. And then we also then need to go from pin 5 to, oh, hang on, we're missing one, sorry. With pin 2, we should go from the trigger to the middle pin on the potentiometer. And then we need to go from pin 5, this one here, to the top of the 10 kilo ohm resistor. And then we need to go from this discharge one to the top pin on my potentiometer. And then that is all connected up. So what we should find is, when we simulate it, and this is how we can see if it works, when the variable resistor is this position, that's in the highest resistance, and our LED flashes. And then when we drag this round, the frequency at which it flashes increases until eventually it just basically stays on when we're at the lowest resistance. And that's how we build the circuit.